Hello guys, welcome to our YouTube channel. In this video, we'll be doing the continuation of integration by U substitution. So we'll be substituting U in the place of a composite function or a component. When I'm talking about a component of the composite function, it's what's within the composite function or the composite function itself. We'll be making it to be our U. In this case, we are given two functions. We are given this function and this composite function. So we have to choose one of these to be our U. It's it. So here to choose what to take as U, it's very advisable that at all times you choose your composite function or the component of the composite function to be your U. So in this case, you're going to choose the component of the composite function, which is x squared plus 5. We let our u to be equal to x squared plus 5. So now we have to express the entire integrand in terms of u. Since this one will be u, everything must be in terms of u, our entire integrand. So even here in place of dx, we must have du. So our du is equals to d over dx of u multiplied by dx. Our u is this. Our du is going to be equals to d in terms of dx of x squared plus 5 multiplied by dx. So our du is going to be equals to 2x multiplied by dx. So that is our du. So in the place of du, we're going to write this. But then we go back to our integrand. We see that in our integrand we have this. We have dx. We also have x. But where is the 2? We see that we don't have the 2. But it means that this is the same as our integrand is the same as, multiplication. How multiplication works is the same as x squared plus 5 multiplied by x times dx. So I have x multiplied by dx. So for me to get it alone, I divide both sides by 2. So this side is going to be du divided by 2 is going to be equals to x multiplied by dx. So in the place of x multiplied by dx, I write du divided by 2. I hope that makes sense. So we also know that our u is equals to this. In the place of x squared plus 5, I write u. Let me this is very important for the rest of our integration. That's why I'm writing it in red. So now let's go down. So let me rewrite my integrand. It's x multiplied by x squared plus 5 all under the square root dx. So which is the same as when we're in terms of u, when we express this in terms of u, is going to be the same as u square root of u multiplied by du over 2. I hope you're together here, guys, because of what we simply did. What we simply did in the place of x squared plus 5, we substituted u. We wrote u in the place of it because of we let it to be what? To be u. To simplify this thing. So we also said that x multiplied by dx is the same as du divided by 2. So we know one of our integration rules, if like we have something like this, 1 over x multiplied by x dx, this is a constant. I can take out the constant out of the integration symbol. It's the same as 1 over 2 then x dx. So which simply means that here I can write it as 1 over 2 root of u du. Okay, I hope you're together. So the square root of u is the same as u to the power of 1 over 2. I want to write it in this form because we know one of our integration rules is that when we're integrating x to the power of n in terms of dx, our integrand is equivalent to our what we're integrating is equivalent to xn plus 1 divided by n plus 1 plus c, where c is a constant. So that is why I'm writing it in this form, so that like it is in the form of x to the power of n. So this is the same as 1 over 2 multiplied by u to the power of 1 over 2 du. So since we know, we're going to say 1 over 2 multiplied by, let me go down a bit, multiplied by u to the power of 1 over 2 plus 1. We add 1 everywhere, divided by 1 over 2 plus 1, to show that this is multiplying this, plus c, where c is a constant. One over 2 plus 1 is equals to 1 over 2 plus 2 over 2, which is the same as 3 over 2. So this is the same as 1 over 2 multiplied by 3 over 2. Sorry, let me go back. So this is the same as 1 over 2 multiplied by u to the power of 3 over 2, all divided by 3 over 2 plus c, which results to be, we know that 1 over 2 divided by 3 over 2 is equivalent to this divides this, is the same as 1 over 3. So it's going to be 1 over 3 multiplied by u to the power of 3 over 2 plus c. So now we have integrated. We are done with integration. We just have to write it in terms of x, because of the initial question asked us to get the integration in terms of x. So I must go back to x. I know what is u in terms of x. So u in terms of x is the same as 1 over is u in u is equivalent to x squared plus 5. So it's gonna be 1 over 3 multiplied by x squared plus 5, all to the power of 3 over 2 plus c. That is our solution. That is our solution. That is our solution. So now, since using the first method, I let u to be the component of the composite function. In the second one, I'm going to let u to be equivalent to the entire composite function. I want to test if it works, but it will work by the look of things. It will definitely work. So here's our what we're going to integrate. We're going to integrate x multiplied by x squared plus 5 dx. So now let me write it in a blue color so that it shows that it's something very important. Let our u to be equivalent to the square root of x squared plus 5. So which is the same as u is equivalent to x squared plus 5 all to the power of 1 over 2. Now our du is equivalent to 1 over 2 multiplied by x squared plus 5 all to the power of negative 1 over 2. Then I also differentiate this, which is going to be 2x dx. So this and this, they divide. We're going to be left with our du, which is equivalent to x squared plus 5 2 actually is equal to 1 divided by x squared plus 5 all rooted under the square root times x dx. But I know very well that in the place of u, in the place of the square root of x squared plus 5, I write what? I write u. So this is the same as du is equivalent to x dx all divided by u. Then this implies that our u multiplied by du is equivalent to x times dx. So now I go back to what we are integrating. Now we have to integrate because we already know what is our u, what is our du. So let's go back. This is x multiplied by x squared plus 5 all rooted under the square root dx, which is the same as x squared plus 5 multiplied by x dx. I know what is x times dx, which is u times du. And I know what is the square root of x squared plus 5, which is what? Which is our u. U multiplied by x dx is what? It's also, I mean to say it's u du. Beautiful. Now the integration symbol. So this is the same as u squared du. Now it's the same as we're integrating u squared. Now let's integrate u squared. It's much simpler in this way actually. So it's the same as 1 over 3 u to the power of 3 plus c. Now in the place of u, I write what? The square root of x squared plus 5. So it's the same as 1 over 3. The square root of x squared plus 5 is the same as x squared plus 5 all raised to the exponent of 1 over 2. So it's the same as x squared plus 5 to the power of 3 over 2 plus c. Now let's go up to see if we got the same solution. Yes, indeed we got the same solution by using different ways. In the first one, we let our u to be equal to the component of the composite function. In the second one, we let our u to be the composite function itself. So this is it's a very beautiful technique to use, integration by use substitution. It's one of the nicest techniques that you use when you have two functions, especially when the other one is a composite function. So please look out on that. If you want more videos on this or you didn't understand anything, please write down in the comments. We'll try by all means to explain. Our aim is to make maths our language. We are tired of speaking English. We must speak mathematics. I thank you.